question number 7 involves angular motion or rotational motion, and I went ahead and put a bunch of formulas up on the board that are going to be very helpful for your exam. Notice that these are very similar to linear motion questions. The only difference is instead of having a linear velocity, you have W or omega, which is the angular velocity. You have alpha, which is your angular acceleration, and theta is essentially your distance. It can be in terms of revolutions or radians. When you do these questions, you're either going to have to convert revolutions per minute or revolutions per second in terms of radians per second squared for acceleration, depending on what it asks you in the question. Now, a very, very important formula to know is how you relate the linear velocity to the angular velocity. If you have an angular velocity and you multiply it by the radius of the circle that you're traveling, you can get the linear velocity. This is extremely helpful for track runners, for building cars like NASCAR tracks. We can also go ahead and expand the equation to say linear acceleration is equal to the radius times the angular acceleration, or distance is equal to the radius times the number of radians traveled. Okay, so question 7 says the wheel of a car is rotating at a speed of 3.0 revolutions per second. So W equals 3.0 revolutions per second. If the wheel has a diameter of 30 centimeters, how fast is the car going along the straight line path? So diameter equals 30 centimeters. The only way to utilize these equations is to make sure that your velocities and your angular velocities are all in terms of radians per second. Angular acceleration has to be radians per second squared. So initially we have to convert and say 3.0 revolutions per second times 2 pi radians per 1 revolution. And this gives an angular velocity of 18.85 radians per second. So this is W, or omega. If we want to find what the linear velocity is, we need to take this omega and multiply it by the radius. This gives us the diameter, so we're going to have to cut this in half to 15 centimeters. Make sure you still convert it to meters when we do this. Everything's still in SI units, so we use V equals RW, 0.15 meters times 18.85 radians per second gives you a velocity of 2.83 meters per second, which is answer choice 7, 2.8. So linear velocity is 2.8 meters per second. Notice here we have meters over seconds. This radians ends up just dropping out. There's actually no correction factor that takes it out. So remember, for this, you want to take your angular velocity, change it into radians per second. Make sure that you use a radius, not a diameter, for this question when you multiply. And then you can use any of these linear equations from an angular to get velocity of 2.8 meters per second.